Okay, so section C is all about shifting and transforming the sine and cosine graphs. So first of all, let's just discuss, let's remember what period means. Period is the length of the interval that it takes to repeat. So if we look at sine, if I start here at 0, when it starts to repeat is at 2 pi. So sine is 2 pi. Cosine, if we start up here, and we see when we get to 2 pi, cosine also has a period of 2 pi, because it takes this distance from 0 to 2 pi before it starts to repeat. Amplitude is the distance from the highest to the lowest point, or the middle point, and from the middle to the low. These are the same. So it's really distance. So first of all, amplitude always needs to be positive. Sine and cosine both have an amplitude of 1. Your principal axis, remember, goes through the middle. So that's just y equals 0. All right. Here. Sorry. If you notice, if we were to shift, here, let me come back to negative 2 pi with cosine. If we were to shift cosine pi over 2 to the right, that would just be your sine function. Or we could shift sine pi over 2 to the left, and that would be cosine. So we can just shift sine and cosine to match. Okay, so what I'm going to do, notice on your note sheets, those are your pi over 2, pi, 3 pi over 2, and 2 pi. If this is 1 and this is negative 1, I'm going to graph both on the same graph. Sine starts at 1, starts at 0, goes up to 1, back to 0, negative 1, back to 0. So this is the original sine curve. What happens if I multiply? So let's first think about this as a table. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine of x, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. So what does it do to the y value when I take 3 times the original y values? 0 will stay 0, the 1 becomes 3, 0 stays 0, negative 3, 0. So the zeros stay in the same place, but we're stretching each of the 1 values by the amplitude. This is our amplitude. This is how much it stretches from the top to the middle, or the middle to the bottom. All right, so what happens when there's a negative in front of a function? First of all, let's just graph cosine. I'm going to come back here to negative pi over 2, then come here. Because we sometimes get into a habit, if you're not real careful, when you get to the edges of cosine, make sure you don't go up. Remember, this is the highest point, 1, lowest point, negative 1. Now, you'll recall from transforming before that a negative in front of a graph reflects. So we're going to reflect and stretch it by negative 2. So if I take my y values times negative 2, the graph itself flips. 0 stays 0. -1 goes to +2. So it stretches it and reflects it, but be very careful because recall, amplitude is a distance, so we still state the amplitude is +2. So we technically, if we have y equals a cosine, whatever this value is, the amplitude is the absolute value. Last but not least, we'll do a translation. And so I'm going to go ahead and graph the original sine curve using a dotted line so we can see how it shifts. You recall x minus pi moves the graph pi to the right. So I'm going to move, and pi, if you notice, is 4 hash marks on your note sheet. So this particular point moves to here. This one moves here. This one moves here. But we can kind of also go backwards. We can kind of notice that pattern. And it just, we just shift it. Okay? So let's look at cosine pi over 4 with a pi over 4 shift. So cosine normally starts at 1. I'm going to show you the original with the dotted line. Now this time pi over 4 is this distance. I'm going to move everything left pi over 4. So that's just 1 hash mark. So this one moves here. This one moves here. Each one just gets shifted 1 spot to the left. You can kind of see how that works. Okay, so the last one, I guess, is period. So typically sine, we look at this, we complete 1 cycle within the period of 2 pi. So when we see a 2 here, we're actually going to complete 2 cycles within the same period of pi over 2. So if we want to calculate what the new period is, we always take the original period of the function. So for sine and cosine, that's 2 pi. And we divide it by the number of cycles to get pi. What that means is it will complete your 1 full cycle within pi. So we can do that a couple of ways. So that means I always look at beginning, middle, and end of sine is 0. So that means beginning, middle, and end now occurs by pi, goes up to 1 in the middle and down to 1 in the middle of the second group. So then if you want to extend it, you see, you can see that you now have 2 cycles within the regular period of 2 pi. Now this next one always kind of confuses people at first. First of all, let's look at the original cosine. So cosine of x over 2, we can also think of as cosine of 1/2 x. So that means we will only see half a cycle in a regular period of 2 pi. So if I take 2 pi and divide it by a half, that means it's going to take 4 pi to complete one cycle. So that means I'm going to be stretching this out. I'd actually have to go out to 4 pi to get my full cycle. Okay. See that? Kind of bad, but all right. So now our vertical shift, think about if we did y equals x squared plus 2, something you're all comfortable with. We just move our parabola up 2. This is the same thing whether you're talking about parabolas, cubics, radical functions, exponential functions. The same thing holds true for trig functions. What it does, this is our new principal axis or midline. So now, instead of y equals 0, we're going to wiggle around where y is 2. So that's our point of equilibrium. So here, instead of starting at 0, we're starting at the equilibrium point, going up to 1, back to equilibrium, down 1 below equilibrium, back to equilibrium. So everything's just shifted. Oh, I didn't go up. Yeah. Everything got shifted up 2. From there, it's the same. You're just treating this principal axis of y equals 2 just like you used to treat the x-axis, but everything else is the same. Same for cosine equals x minus 3. Be very careful. Notice this is not in parentheses connecting it to the x. That minus 3 and plus 2 are out by themselves. That's what makes it a vertical shift. So we're going to do the same thing with the cosine, shift everything down 3, where our new principal axis is y equals negative 3. So cosine starts up 1 from equilibrium, back to equilibrium, down 1, back to equilibrium, up to 1 more. So it's the same curve, just everything's down 3. All right, so that's your basic, just focusing on each piece. And now this kind of puts it all together. So you might want to pause the video and get all of this copied down. Notice absolute value of A. Divide the 2 pi to find the period by the B, the coefficient of x. Be really careful with this. Sometimes this number is inside the parentheses with the x. You may have to divide it out. And notice this will show a translation. This is your x translation, and this is your y translation. Sine and cosine follow the exact same pattern. Okay. So this one only shows a phase shift of pi over 3. So I'm going to go 1, 2, 3, 4. Pi over 2, pi, 3 pi over 2, 2 pi. Normally with phase shifts or horizontal shifts, I always start with the original and then I do a dotted line so I can see. Sometimes the points can get confusing. And so I always start with the dot of, I actually connect these points so I know which dots go with which. Now, pi over 3 is a little bit under pi over 2, so I'm going to shift everything right, pi over 3. So this goes here, this one goes here. Everything's just shifting a little to the right. And there's your graph. Notice this particular one is just changing the period. All right. So we kind of extend this if they want to show the 0 to 2 pi. For letter B, the first thing you need to do is determine what the period is. Oops. 2 pi divided by 3. That means it completes one full cycle by 2 pi over 3. All right, so you've got a couple of options. 1, 2, 3, 4. This is our 2 pi. We really should mark this as 1 and negative 1. All right, so this means I'm going to have 3 cycles within this period. And I'm going to complete my first cycle by 2/3 pi. So I'm going to break it up into thirds. So then 4/3, so 1 1/3. So here's my cycles. My first cycle, my second cycle, my third cycle. All right, so cosine starts up at 1 and it finishes at 1. And then halfway in between, it's down at negative 1. And then it crosses in between. So I'm going to kind of do that for each one. So I get my 3 cycles in by 2 pi. So this shows you how much for one cycle. And then this value tells you how much you need for 2 pi, or for how many cycles you'll get within 2 pi. I'm going to clear off the screen so it makes room. So this is showing me a phase shift of pi over 6 and a vertical shift up 1. So the easiest thing to put into the graph is everything is shifting up 1. And then I'm going to 1, 2, 3, 4. Always match that to 2 pi. Okay, so we move our vertical shift up, so our equilibrium point occurs at y equals 1. Then I'm going to do my original graph of cosine shifted up 1. So I'm going to go start at 2, back to equilibrium, down 1, back to equilibrium. This is everything except for the phase shift or horizontal shift. Then pi over 6 is just really little here. So everything's going to move left pi over 6. So I'm just going to move everything a little bit left. And then I'm going to do a solid line to indicate my final graph. And letter D is the easiest one. Letter D is just a reflection. So where sine, and it's always important to label your axes. Oops. 1, 2. So sine normally looks like this. And remember, a negative reflects it over the x-axis. So it, instead of going up to 1, you go down to -1, and it's just reflection. That's it. All right, this is putting together quite a few things. So first of all, we're going to go up 3 instead of 1 and down 3 instead of -1. If I go 1, 2, 3, 4, that's my 2 pi. Label your axes. And typically, we're going to need now 2 cycles in by 2 pi. So that means our new period is pi. I will complete 1 cycle within pi. So for cosine, that means my beginning and end are both up at 3, the middle down to -3, crosses in the middle. So this is what 1 cycle looks like completed by pi, but always check your interval. They want you to finish it to 2 pi. So we're just going to repeat the same thing by 2 pi. Make sure you're extending your arrows down. Be really careful. That's an easy mistake to make. All right, so they want us to determine the unknowns in this. So where do you think we could start? I want you to look at this and think about, what do we know? This is where I miss having you in class. So they give us this point here, and they give us what this function is. So we're really just looking for our A value, our amplitude, and the D. Okay, so if we can fill in, this is when x is pi over 2. So what I'm going to do is fill in 8 for my f of x. And they also give us this particular equation, which means we can also plug this in. I'm going to write that over here. We now have 2 equations with 2 unknowns. So this is just where we're going to use our substitution elimination. Well, let's make this a little bit easier. What is sine of pi over 2? Well, pi over 2 is just on our graph. You think about at pi over 2, sine is 1. So sine of pi over 2 is 1. So if I take a times 1, I just get a. That just made that a lot easier. 7 pi over 6 is not on the curve. So what we're going to do with that is make our triangle. 7 pi over 6, that's 1 and 1/6. So I'm going to go 1 pi and a 6th, 1/6 halves. Remember, pi over 6 is 30 degrees. So this is our 1, 2, square root of 3. And our sign going down, y is negative, and so is x. So what is sine of 7 pi over 6? Sine is your y over r. So I'm going to take it times -1/2. And that made this one a little nicer. Now, what would make this even nicer is if we multiply the whole thing by 2. So that's going to be 1 equals -a plus 2b. Okay, now if I gave you these two equations, that should be nice and super simple. If I line this up, all of a sudden my a's, when I combine my equations, I get 9, the a's go away, d equals 3. Then I can plug it back into either equation. If d is 3, 2d is 6, a equals 5. So I can now substitute for my a and my d and get f of x equals 5 sine of x plus 3. So we really put a lot of things together in this particular problem. When they give you a generic equation with points, you plug them in to see what that looks like. Then we had to simplify sine of pi over 2 using the curve, sine of 7 pi over 6 using our quadrants, using triangles, and then we had to solve using elimination. So a lot of steps here. All right, last problem. Okay, find the equation of this sine function. That's really important, okay? So first of all, notice everything's been shifted up 1. All right, then it goes, my amplitude is 1 from 1 to 2, so then I don't need anything in the front here. And I complete my first cycle when I get to pi. That means my period is pi. So that means pi equals 2 pi over b, or b equals 2 pi over pi, which is 2. So remember, that's where our b value goes, is next to, it's our coefficient of x. I do not put parentheses around the +1 because this is my vertical shift. It's shifting the y. And this is your final answer.